Hey, what's going on, data analyst? Let's take a look here and run through the guided solution for JMP academic case study JMP033 durability of mobile phone screen part 2. Okay, we're going to work through all these. I will demonstrate the way to accomplish all these tasks in JMP, and let's get started. So first thing we're going to do is look at each question going down the line here. First question, they want us to calculate 95% confidence intervals for the population success rates for the 9 different combinations of screen type and drop height. They're also asking us to interpret those, describe how they differ, and finally create a graph that displays the point estimate of the success rates as well as the lower and upper bounds of the confidence intervals. So after a good amount of research and work on this, I figured out how to do this. They give you a hint here, which is not really a good hint because they don't tell you how to actually do it, but I figured it out, so let's walk through that, and we'll go up here to the top and take a look at the tip for the first question. And this actually is pretty nice up top here where they give you the techniques that they suggest to use for all this stuff. So what we're actually going to do is we're going to make this data into a separate data table that's going to do both parts of this question. So to start this off, we're going to follow the instructions that they give, which is to come over to our JMP file, select Analyze Distribution, and they want you to put outcome into Y. What they call frequency in the case study is actually called count in the data set. So count is going to go to frequency input, and then we're going to take both screen and drop height and put those into the by box. And that's our setup for this. So we'll press OK. And for some reason my JMP always puts new output on the side screen. So here's our new output. So what we have here is based on the by characteristics that we inputted. It's going to give us 9 separate output sections here for each of the 9 combinations. So notice here that we have screen A, drop height 5. That gives us a pictorial representation of that subset of the data, and also gives us a frequencies chart down here. So next thing we're going to do here is we're going to turn on the confidence intervals, and rather than do that one by one, there's a cool way to do that all at the same time, and that is, before we do anything else, we're going to press and hold Control on Windows or Command on Apple. While pressing and holding that button, select Outcome, little red triangle. So the top outcome, it wouldn't matter which of the 9 outcomes you selected here, but just do this for one of them. So Outcome, confidence interval, 95%, all the time holding down Control, and select 95%. So notice now that it's given us the information of interest here. What they asked is for the 95% confidence interval for each of the 9 combinations with probability of success as the variable. So notice that each table gives us both fail and success confidence intervals. So probability success is 90% for this screen A, drop height 5, and the lower confidence interval is 0.769, and the upper is 0.960. So that's awesome so far. All right, awesome job so far on that. Now, what we're going to do next is implement the hack that I developed for getting this one done and getting it done right and efficiently. So at this point now, if we wanted to, we could screenshot each of these 9 different individual confidence interval outputs and include them in a report. But if we go over here and look at the report, and specifically the question that it's asking us to do here is calculate the 95% confidence intervals, provide their interpretation, describe how they differ or compare. So they're not saying anything about graphics or anything specific, how to report them there. So what we're going to do next is we're going to make a table that's going to just have the relevant information in it, and that table will be the answer to the first part of question 1. And then from that table, we're going to do the second part of question 1, which is to create a graph that displays the point estimates, which is where my super hack's going to come in real handy here, because you'd never figure out in a million years, I don't think, unless you're a jump expert, how the heck to get that set up. So what are we doing? Okay, so now what we're going to do is we're going to go to our output that we just made over here. I'm going to click in that just to make sure it's the active window, and just click by clicking in white space. So now let's go down to, and you can go to any of the, confidence interval output charts, and you want to make sure your mouse is somewhere within the chart. And we're going to go down there, click on that, click on Make Combined Data Table. Okay, and that's on my site screen, but let me go ahead and also save this script. So whenever I do any work in JMP, I like to always just by habit save the script so it's available if I want to go back to it and reference it later. So to do that, you always go to your very top little red triangle, select Save Script, and always select To Data Table. And it's going to ask you for the name of that. It's going to give it a non-descriptive name, so let's just call that question 1, so we can identify it amongst ourselves. And notice here that we now have that script up there, Q1. So if I close that down, if I come over here, I can either left click on it and it'll rerun all that, or if that doesn't work, right click on it and press run script there. So awesome. So there's that. So we have that. We don't need the output anymore. We've already made the combined data table. So let me drag that over here and introduce that. Okay, awesome. All right, so I'm looking at the new data file that we generated. So this is a whole other data table. It's a different file from the first file that we used, JMP file. So what we're going to do now is, what I like to do at this point is to save as. Notice the name is now Untitled 4. So let's call this one Question 1 Work. So that's just going to be our let's call that Q1 work table and save that. We can verify that it's saved up here at the top left of the window. Okay, now we got a bunch of crap in here that we're not interested in at this point. So the only thing we're interested in are the 9 pairs of drop height and screen that and their respective success rates. So before I do anything else here, what I'm going to do is left click in my table column header, the table column, the first column here. Notice that that all has the same information in it, so that's not going to be of any use to us. Likewise, Y, that's just kind of telling us where we derived this subtable from. And with both of those selected, let's hit right click in one of the blue tops and delete columns. Awesome. So we got rid of those, so we can check that off. I'm going to do Control S, save my file. JMP doesn't autosave, so if you're putting a lot of work into one of these things, make sure and save it periodically. So now what we're going to do is we're going to get rid of all of the rows in here that are not the success rows. So what I'm going to do is I'm going to click in, I'm going to left click on level fail. I'm going to control left click on level total. And with both of those selected, I'm going to right click on either of those fail or total selected cells and press select matching cells. So notice that now it's circled all of the cells that don't have success in it. So now let's get rid of those. We're going to go to the left-hand column, the row index column, and in any of those blues, right-click, and delete rows. Wow, look at that. So, okay, at this point I'm going to Control S to save. And I'll just click over here to get rid of that selection. And we now have our answer for the first part of question 1. Here is each drop height and screen combination, its corresponding probability of success. That's our point estimate. And we also have the corresponding lower and upper confidence interval limits. Now, to get ready for the next step of this, what I'm going to do is click on the probability column, and after I left click on probability to make that column header blue, I'm going to go up here to columns, reorder columns, and move selected columns. From here, if I didn't click anything here, it would move it to the end of the table, the right side, but I want to put it after, and I want it to be between the two CI, the lower and upper, so I'm going to tell it after lower CI and OK. So now we have lower CI, probability, upper CI. That's going to be important for the next step that we're going to do. So I'm going to Control S, save the file. Okay, moving on to the second part, which is creating the graph of that data that we just generated. And this is a complete hack. I would honestly have no idea how to do this in JMP without this brilliant tutorial that I found that shows exactly how to do what we're looking for here. So what I'll do is I'll put the link for this tutorial down in the comments section of this video. So if you want to access it directly, that's awesome. But I've kind of customized the tutorial steps for the graph to our problem data here. So let's knock this thing out. Follow along close. This isn't really an intuitive process here. So, all right, let's do it. So I'm going to go to Graph at the top, Graph Builder. All right, so we've got our Graph Builder open here. We're ready to get to work on that. So first part of this is we're going to take and drag our variables into the X and Y axes of the Graph Builder. So the X axis is going to consist of the variable drop height, so click that, and I'm going to Control click screen because I want both of those to go in there, and then take both of those and drop those down there into X. Now, same process here. We're going to click lower CI, Control click probability, Control click upper CI, and with all three of those blue, drag those over here into the Y drop box. While we're thinking of it, let's change the name of the Y axis to probability of success. So we got that done. We don't have to worry about that later. Now, doesn't look like much information is being communicated clearly there. So let's do some JMP voodoo stuff to this, and we're going to make it be what we want it to be. So let's see. So the icon at the top for points is the one on the left. That's the one with the dots in it. We're going to make sure that one's selected. That should be already selected, but just make sure that one's lit up. That's what we're getting this from. Now, what you're going to do is press and hold Shift, and while holding Shift down, press on the bar icon, and it's going to give us that, which is scary looking, but we're going to make it exactly what we want here in a little bit. So we've now got that. Now, anywhere in the graph, we're going to right click and we're going to select bar style, interval. Oh yeah, that's looking much better there. Then under, and let me give us a little bit of room here, under points on the left side over here, we're going to click on the little gray triangle next to variables, and we're going to deselect lower CI and upper CI. We're going to then go down to the bar section down here. We're going to click on that little gray triangle and look at all those variables, and there we're going to deselect probability, or the prob, our point estimate. And wow, look at that. That's exactly what we're looking for here. So with that being set up, what we have, and let's go ahead and save this script first thing before we mess up and lose all that work we just put into that. So save script to data table, and I'm just going to call this one the Q1 graph. Okay, so we've got that saved as a script up here in the data table, and what we can do now is go up here to the upper left, hit the done button, and there is our finished output for question 1. So notice that one of these bars is highlighted, is darker black, and that's because we have a row and column selected in our data table. So if we go up here to the upper left of the data table and click in both halves of that upper block there, that's going to deselect everything, or you could just do that through the menu, but make sure everything's deselected. And then I'm going to go down here to the bottom of my data table. That shows all the open windows. Double click on that. That's going to raise our completed output here, and there we go. That's exactly what we were looking for. So now we have A, B, and C at a 0.5 height over here, and on the y-axis we have probability of success. That goes from a maximum of 100% to, on this scale, a little bit below 40%, and we can now interpret easily, but compare these confidence intervals to each other. So let's look over here at the 1.5 meter drop height. So notice that each of these sets down here, we have 0.5 ABC, 1 ABC, 1.5 ABC, and what we can do is, looking at the 1.5, for example. All right, so we're good to go on this one. And let's move on to the next one. Hey, what's going on? We're back in now. Gonna do question 2 and 3. Both question 2 or 3 is the exact same technique. We're just reversing screen and drop height. So we'll run through question 2 here and take a look how to do that. So here on the assignment is a description of doing this test. So I give you a bunch of information here, but ultimately what we're going to be doing is we're going to be doing a chi-square test of independence, and we're going to be doing 6 individual of those tests. We're going to do it at level A, level B, level C, and then at level 0.5, level 1, and level 1.5. So let's take a look at the first one that we're going to do. And each of those 6 tests has a corresponding hypothesis, and the hypothesis is structured as shown on the screen here. So the null hypothesis, if you want to think of it in words, the null hypothesis is that all of the population proportions are equal based on the 3 sample proportions, and the alternate hypothesis to that is that all of the population proportions are not equal to each other. So don't make the mistake of replacing the H null equals with not equals, because that would say that every proportion is not equal to every other proportion, and that's not what this test does. This test says either the null hypothesis that they are close enough together to be considered statistically equal, or the alternate that at least one of those pairs of proportions differs sufficiently to be considered statistically different. And once we have findings on that, then we would typically perform follow-up testing at a pairwise level to figure out which exact pairs differed from which exact other pairs. So let's get to that. We're going to go back to our initial data file. So here we have the initial data file with the question 1 script saved in that. So let's go for this one to analyze. And because we now have 2 variables that are being inputted into building the model, we're going to go with the fit y by x. The first problem that we did, we used distribution because we were only looking at one value, and we followed the way they said to do that one. But here we have 2 values that we're comparing, and so we're going to do a fit y by x, and that is going to get us into this launch platform here. And so we're going to start by taking outcome, and we're going to throw that into the y response. We're then going to take, for question 2, we're going to put screen in the x factor, and we're going to put count in the frequency. Count in the frequency. All right, awesome. So we got that set up. Notice that in the lower left here, jump looks at the types of variables that you've input and decides which is the test to do given those variable types. So here we have both of them are categorical variables, so it's going to give us the contingency output. And let's drag this over here. Okay, cool. So here we have our initial analysis, and we have to tweak this one more thing in order to test what they're wanting us to test here. So here, this test is now looking at every screen A against every screen B against every screen C, and doesn't divide them up by the drop level. So let's go ahead and do that. So we're going to go to the very top of the little red triangle. We're going to take local data filter. That's going to open this up. We're now going to use the filter to isolate every drop height. And to do that, I went to little red triangle in the main output, picked local data filter from there, selected the variable drop height, and this tells us there are 3 unique values within drop height, and we now can select which one or which multiple ones we want to be included here. So let's go ahead and click on the 0.5, and that's going to give us our first output that we're putting together here. So by clicking on 0.5, that restricts the data only to those values that the data values that have a drop height of 0.5, and we can verify that by looking at the total down here. That's 120, that's correct. And so now we have screen ABC and their relative success and fails in here. And what the test is doing is it's going to test whether or not there's enough evidence to support the alternate hypothesis here. And remember that says that at least one of the proportions differ significantly from the other. So this is our first of 3 test documentations for question 2. So what I'm going to do is, before I do anything else, go to the main little red triangle on this output, tell it save script to data table, and I'm just going to tell this one question 2 at the 0.5 level of analysis to help identify that. So now let's run the second scenario real quick, which will just stop using 0.5 and we're going to switch over to 1, and that should match up with what they have in the table output. And so notice that by just clicking on one over here in the local data filter, we now have only the 1 meter drop heights for the A, B, and C screens, and the 150 total verifies that. And also, in the report, this is the exact run that they gave us the demo documentation of here. So here we're testing the proportion of screen A is equal at a 1 meter height is equal to the proportion of screen B at the 1 meter height is equal to the proportion of screen C at the 1 meter height, versus the alternate hypothesis that at least one of those proportions differs significantly from another. And that's what we're looking at here. And to run this test, we'll just go down here. We could use either of these p-values. We'll just use the likelihood ratio one. And as always with any hypothesis test throughout statistics, we're going to have an alpha value in mind when we're performing the test, and we're going to receive as a result of the test the p-value. The p-value here is in the prob greater than chi-squared column, and our p-value for this test is 0.0403. And the universal rule when performing such a test is to reject the null hypothesis if the p-value is less than alpha. So in this case, our p-value for this test of equality or lack of equality amongst all the levels comes up with a p-value of about 4%. That's less than 5%. Therefore, for this test, we're going to reject the null hypothesis, and our hypothesis test findings for this particular test are that at least one of the proportions at the 1 meter height differs from another, based on the p-value being less than alpha. The test itself doesn't necessarily tell you anything about which pair is different or anything like that, but we could look up here at the mosaic plot, and that'll give us a good graphical insight to that. So based on seeing this, my presumption would be that the BC pair are found to be statistically equal, but A and B would be found to be statistically not equal to each other because there's a big difference there, and A and C probably would also be found to be a big difference there. And it's kind of easier to just look at the red parts of this graph, which those represent the fail proportions, but because fail is complementary to success, it gives you the same exact insight. So that is how to do that. So like this one here, we'll just save this one as not that thing, but go here. So save script to data table. We're gonna call this one Q2 at 1.0 meters. Okay, got that up there, and cool, we're good to go. So now you can use your favorite screenshot tool, circle all this stuff here. Usually I don't include the mosaic plot when I'm reporting findings in a project such as this. You certainly can, but you want to copy the contingency table and the test results down here and include that in your report for the research you did on question 2. All right, and that covers question 2. As I said, question 3 is the exact same scenario. We're just going to reverse screen and drop height. So follow the same setup you did for question 2, but just put drop height in as the X variable, and do your local data filter and split it up between the screens A, B, and C. So that'll take care of that one. All right, let's move on. So we got 1 done, we got 2, 3 done. So now we're going to do 4 and 5. So just like 2 and 3, same exact procedure here. We're just going to be reversing screen height or screen type and drop height between 4 and 5. All right. So here we are. We're back to our initial data set, and so after deciphering what all this says, what they want us to do is to for each possible pairing, which would be like A versus B at 0.5 meters, A versus C at 0.5 meters, and so on. They want us to get a 95% confidence interval and run the hypothesis test of the difference between those two samples. So we're doing our a pairwise test of equality for those. All right, so let's run this set up here for question 4. So for this one, we're going to do analyze, fit y by x, and we're going to put outcome over to screen. We're going to outcome to y, that is, and screen over to x. Okay, and then count is going to go to frequency, and there we go. Okay, so that's our setup now for question 4. The only difference with question 5 is that instead of putting screen into x, we're going to put drop height into x. And notice that at this point we haven't entered the other one of those two in there. So here we haven't told it anything about drop height yet. So go ahead and run that, and that's going to look like this. And now what we need to do is we're going to set this up to give us the testing scenario that they want us to run here. So first thing I'm going to do is go to local data filter, and from that local data filter pop up on the left, I'm going to double click on just drop height, and that's going to give me the 3 levels of drop height to choose from. And I'm also going to, once I open that drop height one up, I'm also going to click and tell it the other things, which is screen here. So now I've got all 6 of the drop height and screen levels available. And for question 4, what we're looking to do here is do all of the possible pairwise combinations at a drop height of 0.5. So I'm going to hit that one, and now I'm going to tell it, let's do our first possible pair. So we'll just start with A and B here. So I hit A, I'm going to control click on B, and let's slide this over a little bit here. And now that we've got that set up, the computer is going to know that we have 2 samples that we're testing here, and those being A and B based on our local data filter settings. So we're going to cruise up here to the main outputs, little red triangle way up at the top here, and now you're going to find 2 sample tests of proportions on here. This wouldn't be on here unless we had set it up so there were only 2 samples. So make sure you do your setup over here first, and then you'll get this available. So click on 2 sample test of proportions, and because we're testing the probability of success, we're going to go down to the very bottom here and click on the success bubble. Okay, now that we've got everything that we want for this question, so what I like to do is minus down the things that aren't relevant. So our bottom output here has everything that we need. So I'm going to go up to the little gray triangle next to test, give that a click. That's just going to fold it up. Going to do the same thing with the contingency table, and going to do the same thing with the mosaic plot. All right, awesome. So now we have just the output of interest for our first pairwise analysis. So let's cruise over here and take a look at the hypotheses for this and what we're figuring. Okay, so here we have our confidence intervals and hypothesis test. Actually, we're just looking at the hypothesis test here. So the hypothesis test is that, and you could write it either way, as whichever you prefer out of these two. But essentially what we're saying is that H null is that the difference between those two proportions in our test, we're doing A and B at the 0.5 level. We're saying null that those two are statistically equal, and alternate HA, we're saying that those two samples are statistically different from each other. In other words, there's enough difference between the proportion of A at 0.5 and proportion B at 0.5 to meet the alpha 5% requirement that they do differ. So looking at our findings for this first test, notice also down here that in the section here, it's called the adjusted walled test, we have 3 p-values, and that relates to the fact that we potentially could be testing any of 3 scenarios here. We could be testing that A is less than B, A is more than B, or A differs from B. And we're doing the third one, that differs from B. Commonly that's called the test of equality, but to get to that one, we need to go down here to the third output, and notice that it has equals 0 on the end. So it's telling you match this up to your null hypothesis, which is that A minus B is equal to 0. That's the null that we're testing. In other words, there's not a significant difference, is what that's saying. And our findings for that first test here have a p-value of 0.0846. So at our 5% alpha, 0.846 is not less than 5% alpha, so there's not enough evidence here to reject the null hypothesis. So in this case, we find that at the 0.5 drop height, that the proportion of A and B success are statistically equal. And we're just going to repeat that again for the remainder. So let me save this one. Oops, you don't want to do that local data filter one. You want to do the main little red triangle, save script, to data table, and I can just call this one Q4 at the 0.5 level using screens A and B. Okay, and that script adds up on there on the script list so that we could invoke that again if we wanted to. You might want to just screenshot each of these sections here, from the 2 sample test proportions header down through the bottom p-value, and then you can use those to interpret it. But that's the process here. And also for the next part of this process, they want us to make a graph similar to what we did in step 1, and so we're going to need to manually transpose the proportion difference, the lower 95 and the upper 95, over to a new data file. So we'll look at that next, but let's look at how do we make this change to the different other levels. So what I'm going to do here, and this is going to probably look scary for a second, I'm going to click on C to turn C on, and notice that test went away because now we have 3 samples in here. But let me click on B to turn, ooh, wow. Okay, well, we just want to do, let's turn them all off and go to B and C, and wow, what is going on here? B and C. Okay, wow, that was weird. But anyway, there's, oh, we didn't even want, we wanted A and C, but anyway, we got B and C, so B and C at the 0.5, click on the success thing down here, and for that p-value test of equality, we get 0.5558, that's not less than alpha, therefore there's not enough evidence that these differ significantly, so they're found to be statistically equal. I could again save that script up here if I wanted to. Finally, for the third one, let's try and get this thing to cooperate a little more. A and C, whoa. A and C. JMP can be a bit finicky at times, as I'm sure you've observed yourself at this point. So here's A and C at the 0.5. P-value is 23%, roughly, not less than 5%. So overall findings at the 0.5 drop height are that none of the pairwise differences differ amongst those heights, which should correspond to the findings we made in questions 2 and 3. That I can infer from these findings that overall the chi-square test of independence is going to say that they're all statistically equal to each other, I would expect. So in any case, that's how we do that, and let's take a look at doing the second part of this question now. Okay, so as far as the second part of questions 4 and 5 goes, we're asked to create a table and graphic summarizing the results. In other words, a table and graph for the p-values and a table and graph for the confidence intervals. So essentially the same thing we did in part or question 1, but it's going to be 2 tables, and one of them would be with the p-value. Now, I don't have any idea how to get the outputs to automatically get in a table here like we did in question 1. So we're gonna hack this by just making a new data table, and let's see here. So we'll set that down there. So I'm going to save this one as save as this one's going to be 2-3 question 4. We'll call this one question 4 work data table work. Okay, cool, awesome. So that's saved now. So what we got to do here is we got to essentially manually assemble all this data. So let's just do this. Gonna go. Ooh, wow, that was weird. Okay, so. All right. Let's see here. So I'm going to add a new column, and this one's going to be called drop height. This data type is going to be a character, even though you could leave it as number because it is still a number, but we're thinking of it as a nominal, but let's make it ordinal just to make JMP happy, and not that JMP would care about that, just to make us happy, I guess. So let's see, number of columns to add. Let's see if we can kind of automate this. So we need p-value 1, 2, 3, so we need 4 more columns in this. And okay, cool. So let's edit the name of that one. Drop height 1. Let's change that to drop height. Okay. Screen drop height, and you know what? This is gonna work better if we do it this way. So let me see. I'm gonna double click there to well, you know what? Let's just get rid of that one, and we're gonna do this. We're gonna say, okay, our new column, we're gonna call this one p-value, and that is definitely going to be a numeric and continuous data type, so we'll leave that set there. And what I want to also do is add 3 more similarly formatted columns to put our confidence interval junk in. So here I'm just going to rename this one to be plain old p-value, and okay, that one. This one is going to be the lower confidence limit, just lower, okay, we're going to call this next one, going to call this next one point estimate, because that's the middle point. And our final one here is going to be upper. All right, cool. Okay, so we got that thing all set up there. So now let's get out of the way making our labels here. So in this first analysis, we're doing, well, you know what? Okay, we need one more column. We need to have, let's see here, new, so we're going to insert a column. That one's going to be called screen 1. I'll make that into character, numeric, I'll just call it ordinal. It doesn't make any difference to jump whether that's set up there. We're going to change this one to be screen 2, data type, character, looks good, change that to ordinal. Alright, sweet. So now, just a matter of doing the work and transferring the findings into this new table. So we can kind of set this up ahead of time by, I'm going to turn on the caps lock, so I'm going to go with A there, I'm going to put A there, going to put A there, I'm going to go up here, and I'm going to tell it B, I'm going to tell it C here, I'm going to go down here and change this to B, going to go to the next cell to the right and type C. So that's all our 3 pairwise combinations for the first drop height. So that first drop height is 0.5. Pretty easy to just type that a couple more times. So we got that set up. So now and I'm not going to run this whole thing here, but I'll do this to show you how you would set it up in there. So let's also run A and B at a 1.0 meter drop height. So okay, cool. So let's slide this over here and populate our data. So to do that, we already set the script up, so I'm going to go up here and rerun the Q405 drop height with A and B. Gonna click on that, run it, bring this over here, and wow, looks like every time you run that, it's gonna go to the fault or the fail response. So let's click on success, and it's probably gonna work out to be easier to just do this. Keep changing the local data filter and then take a snip of your results here. So like one way to do that would be not by doing that. We don't want to change that. Let's see. So if I remember right, the weird plus tool. Yeah, that's the tool, the selection tool. So click on that, and if you click on the header for 2 sample test proportions, gonna make all that blue. So Control C, go to your report document, Control V, and you're going to get a screenshot of that exact result there in the original graphic format. It's not text. So cool. So that's our data for that one. So oops, and let's turn the selection tool off by turning the arrow button on, and now we'll transfer this findings over to our new data table. So drop height of 0.5, and the pair is A minus B. So A minus B at 0.5, that's my first line in there. For that one, we have a p-value of .0846, and a lower confidence interval value of negative 0.2035. I'm just going to round these as we go to 4 decimals. Point estimate, that's going to be the proportion difference from the table, negative 0.1, 10%. And upper is 0.013 0. All right, cool. So we now have that data for the A and B in there. So now let's do, let's change this over to 1 meter and run that one. So let me click on success here, and all right, so now we're doing and we'll just verify this by checking what we selected in the local filter. So we're doing the drop height of 1 meter and doing the difference between A and B. So that's going to be a p-value of 0.034 and a lower of -0.2591 rounded. Proportion difference or point estimate of -0.14. Upper limit -0.0102. Okay. And so we've got that set up. Let me just real quick, I'm gonna get us one more set of values to put into the chart here. So of course when you're running this, you want to do this for all the possible combinations. So let's just do an A and a C here. Dang it. All right, something's not getting along with us well here. Let me try this again. A and C. Okay, that seemed to do it. So I'll minus back down the test thingy here. Set this to success. And we now have A and C at 0.5 with a p-value of 0.2324 and a lower of -0.1887, point estimate -0.75, and an upper of 0.0458. All right, cool. And like I say, I'm just doing this with enough data to show you how to do to make the visuals on this. So matter of fact, why don't we let's just do B and C for the heck of it, and include that in there. So B and C. Jumps weird. C and B. Ooh. C and B, minus that thing down, select success. So for that one, we're looking at, see, B and C at 0.5 is going to be 0.5558 p-value. Lower is -0.0554. Point estimate positive 0.025. Upper 0.1030. That's weird. That's like the same one that we got on, well, no, it's different than that first one. Okay, cool. So, why is it changing that? Oh, it didn't change it. That was what it was. Okay, so there's our data setup. Okay, and we're ready to move on to the second part of question 4, which is identical to 5 with the screen and drop height reverse. So what I'm going to do is I'm going to take this new data file, our question 4 working file, and I'm going to put that on our screen here, and we can now proceed with making our graph. And before we do anything else, we're going to make one more column in here, and I'll show you what we're going to do with that. So let's do column, new column. Wait a minute, it's going to put it at the end. Oh no, it's not. Oh, and here's where you tell it where to put it in. Well, apparently we should have selected a column in there, but we'll put it in the last for now. Let's see, this one's going to be a character column, and we're going to call it pair name. And let's see here. Okay, we'll add that in there. And then next thing we're going to do is we're going to make a little formula here. So column properties, down at the bottom there, formula. And by doing that, it's going to invoke the formula editor box here. So what we want to do is we want to put the screen 1 and screen 2 in one variable, and so we describe the pair comparison. So in order to do that, we're going to use one of the almost infinite number of tools and formulas that they give you over here, and we're going to do, let's see, that one's going to be so let's start off with screen 1. So I can double click it there. That's going to go into our editor box, and with that editor box being blue around the edge, meaning highlighted, we're going to go in here to character, and we're going to select concat. And what that means is it takes two different text strings and merges them into one. So the contents of screen 1, we'll start that off. Now we're going to enter our middle part, and how to set this up is up to you. You could say like versus whatever, but in this case I'm just going to, actually I'm just going to put a minus in here. So you got to put this in quotes, so when you press your single quote in the editor box, it's going to open up this weird little pop-up, and the pop-up starts with 2 quotations in there. So make sure and that your final thing winds up with the right quotation setup. So here we have the value screen A and a dash, and let's go with the value of screen, ooh, wow. And let's go with, oh, I know what I did. So we're going to select the whole thing, and we're going to again tell it concat, and we're going to do screen 2 now. And that should be what we're looking for. Let's OK that. Let's OK out of here. Okay, awesome. So that's what we wound up with. Now, just to make this thing a little more readable, let's go to, how the heck do we move this thing? New. You wouldn't think it'd be so hard to move in here, but it actually is. Let's try this column. Blah, blah, blah. New column. Reorder, that's what it is. Okay, move selected columns, and we want to move it just after screen 2 variable. Okay. All right, cool. So now we got that put together, and now we're all set to run our analysis. Graphing, that is. All right, so let's do the p-value one first. And so we're going to go to graph builder, and let me drag this over here, and there's our graph builder. So similarly to the first question, we're going to do, actually we don't want to do screen 1 or screen 2. We're going to do pair name and drop height. Those two are going to go into the X here, and that's going to set up our bottom axis as we want it, and into Y for this first visualization, which is just looking at p-value. We're going to plop in the p-value there, and it would be kind of nice if we could get a line to appear on here at 5%, because that would show the significance or show each p-value relative to the alpha significance cutoff. But I don't know how to do that, and I really like how this one came out, so I'm just going to say we're done with the p-value chart because we did what they asked, and click on done there. So yours, of course, will have 9 combinations here, all 3 of the heights, and then A, B, AC, BC, and if you wanted to, you could probably flip those upside down to get get it sorted by the other way, pair name and drop height. Also rename your bottom axis maybe. I could have given pair name a better name overall, but let me save this. So save script to data table, and we're gonna do let's see, this is 1, 2, 3. This is question 4, and we're doing the graph of p-value. Okay, and okay on that. So again, yours, you would have put all 9 of the possible combinations in here, and we're done with that. So X goes there. Now, set up for the second part of question 4. Graphing is going to be, let's see, how did we do that? Oh, we want to go to Graph Builder. And this is actually the same exact thing that we did in the first part. So let me take pair name, and let me try something here. I'm going to put drop height in there first, and then I'm going to put pair name down there. And so yeah, it kind of looks like you're able to maybe, whoa, what's going on there? I don't want to do that. And then pair name is going to go in there, just like that. Okay, cool, awesome. So let's see, why do we have 5 in there? There's only 4. Drop height, point, oh, let's see, wow, something went bad there. Let's see, pair name goes into there. Drop height also goes into there. Apparently you got to avoid the, what the heck, there's like different purple sections in there that you can put it in. So that's drop height. Oh, dang it. You know what? I forgot to do pair name and drop height. We got to circle them both. Okay, cool. And so they're in there now. So that's what we want. We got our 4 demo setups here. And now we're going to do this one just like we did that first problem. So lower, control click point estimate, upper, control click that one in. So once we get all 3 of those blue, drag it over here to Y. Okay, just like we did in the first question, we're going to now make sure that the dots icon up top here, and only that one is selected. We're going to press and hold shift, press the bar icon at the top to get both of those selected. Now we go inside the table, click right click, bar style, and interval. The style of bar we're going to need after this one is one that's got a lot of strong liquor rated. Okay, so interval, then we're getting there on that one. So now let's go over here to points, variables, and we want to turn off upper, lower in points, and in bar variables, we want to turn off the point estimate. Wow, look at that. And that's what we got. Something super wrong there though, because A and C at 0.5, 0.0 is telling me 0.55. Why is that telling me 0.55? Hang on. And it's doing that because I punched it in wrong up here, so let's change this one to 0.075, which I'm sure is what it should be. And oh, nice. And there we go. So there's our pretty output showing each of the pairwise confidence intervals and their comparisons. Yours, of course, again, would have all 9 of those on here. But we like that one, and we're going to call that one done. And let's save script here as Q4 graph, and we'll just call it CI, meaning confidence interval. All right, cool. we got that all set. And now to put this one in your output, if you want, you could just click on the selector tool there. And then any section you click on, it'll select that. But if you click the top head, it'll select everything. Do your standard copy, Control C on a Windows rig, and you'll have that in your clipboard, and you can paste it. So, so that takes care of Q4. Now, same drill for Q5, just we're going to reverse the screen and the drop height. So, let's take a look over that. Assignment notes above there, and they just document the heck out of these, don't they? So what we just did is what we're seeing on the screen here for question 4, we did each screen type at the same drop height, or screen level, screen type at each drop height. So, and we just thoroughly talked through that, so I'm not going to rehash that. But question 5 is just reverse of that. We're going to now be doing, so like for example, the first one would be both of the screen type A levels 0.5 versus levels 1.0. So that would be comparable to our first test here, which was screen A and screen B, both at the drop height of 0.5. And then the rest of doing question 5 is going to be the exact same from what we did in all this work on question 4. And probably the easiest way would just be to make a new separate working file. So question 5 working and do this same stuff. So so that's gonna take care of question 5 mercifully. Okay, let's move on. Okay, now we're back to our main data set, and notice that other than the scripts that we've saved to here, nothing has changed within the data table. So we're ready to move on to question number 6. Question 6 tells us, asks us to calculate and construct 95% confidence intervals for the population relative risk for each possible pairwise combinations between the 3 screen types for each of the 3 drop heights. So what that means is we're going to be doing 3 confidence intervals for each drop height, because each confidence interval is going to involve 2 levels of screen types. Alrighty then, let's take a look in the report at the details of the process that they provide here. So what we're doing now is confidence intervals for relative risk. So to run this one, we're going to start this one off exactly the same as we did initially, at least for question 2, that is. So analyze fit y by x, outcome goes over here to y. We're going to take screen and drop that over to x here. Put count in the frequency, tell it okay, and let's drag this over here where we can see it. Alright, cool, there we go. So so here we have our starting box, just like we started with in question 2. Just like we did also there, we're going to do the local data filter, and we're going to turn on both the screen filter and the drop height filter. So okay, so we're ready to rock now. So first combination here is, and let's look at the chart here. So notice that they have the relative risk ratio, and the hypotheses work the same way they did in where we were testing for difference, but now the base value for a relative risk ratio is 1. So we're doing proportion of one sample over another sample, and that fraction becomes the relative risk. So we're just interested, does that risk differ significantly from 1, or does that risk statistically equal 1? And so let's go ahead and cruise over here to our setup box. And our first one's going to be A and B screens at the 0.5 height. Okay, and now what we got to do after you set that up is to make sure that you got your two samples going on, and you've restricted it to just the 0.5 drop height. Let's go to, what are we going to go to? Oh, little red triangle on the main output here, and you're going to tell it relative risk. And notice that we have this little input here. So the risk ratio is success. That stays the same. And I'm not sure exactly why it works out like this, but if you click B, that should give us what we're looking for here. So okay, down there on the bottom, you see relative risk of success A over success B. And that relative risk is 0.9. There's the corresponding confidence interval, and based on that confidence interval at a 5% alpha, in other words a 95% confidence interval, there is almost evidence but not quite. So if the upper 95 had been over 1.0000 here, then that would be correspondent to doing a hypothesis test, and the test would have said there that it is equal to 1. But in this case, the 1 is just a tad outside our interval, so therefore this test would find that relative risk ratio, portion of A versus portion B at the 5% drop height, does differ from 1. Okay. And probably we don't need to do any graphs or anything with this, so this is all we got to do for this part. So maybe go down and click on and a little shortcut you can use is on your keypad, press S, and that changes it to the selector tool, the weird plus tool. So click on relative risk, Control C to go get it to the copy to the clipboard, go to your report, paste, and then go back to the jump file, and press A to change it back to the arrow button. So that's your first one, A and B at 0.5. So now, having done that one, we're going to turn off B and turn on C. And looks like that erased our stuff there. So let's just do this again. And there's that one. So that's the second of the 9 in question 6, A versus C. That one, now here we have the opposite finding. We find that there is insufficient evidence that A and C differ, and therefore they're statistically equal to each other because the value 1 of relative risk falls above 82% and below 1.03, 103% if you want to call it that. It's just a ratio here, so that's not percent, it's just 0.82 and then 1.03. So cool and awesome. And now we would do next the B versus C, and then do your little thing there again. Relative risk, set C, okay, and boom, there you go, there's that. So do that 9 more times total of 9 times. So the 3 pairs of screens at 0.5, the 3 pairs at 1, and the 3 pairs at 1.5. And that's going to then give you the results for that. Now, as far as how to interpret any relative risk ratio, so looking at the one we have in the current output here, we're doing both are at the 0.5 level, so that goes away because that's consistent. So we're comparing the success probability of level B over the success probability of level C. And if you think about it, simple math kind of approach, then if the top is a bigger number than the bottom, then that overall number is going to be higher than 1. So in this case, the relative risk being 1.03 approximately is higher than 1. So that means that the success of B is a little bit more than the success of C. And we can verify that by looking at the mosaic plot here. So B had looks like 100% success, whereas C had a 97.5 success. So that's how to interpret relative risk, and likewise, if a relative risk is below 1, that means that the top is lower than the bottom, and I don't know how to interpret relative risk beyond that. And to just make a final note on question 6, let's cruise down here and look at that one. Notice in here that it doesn't say anything at all about performing a hypothesis test or deriving a p-value. So we don't have to worry about that at all. It just says calculate the intervals and then interpret them. So we know how to determine significance on here. If a given relative risk ratio is significantly more than 1 or significantly less than 1, then that indicates that either the numerator or the denominator of that pairing has a significantly different proportion of success, and that would be the interpretation there. All right, almost there. It's our last question here for having to do analysis. The rest of these are interpretation. So let's rock. Now this, the overall setup here is pretty much the same as question 6 is. The only difference is now we're doing odds ratios instead of relative risk. So let's look over here at the notes for this. So what is an odds ratio? An odds ratio is, so for a given, so first thing we're going to look at is the single odds ratio. So for any individual treatment, like we could do screen A, drop height 0.5, that would have its own odds ratio. So proportion of, or success proportion of A is 90% because 4 of 40 in A 0.5 failed. So 90% over 10% is going to be the odds ratio for A05. And to do what they want us to do here, okay, I guess that is just called the odds. That's just for the 1, it's just the odds. Okay, so like the odds for A05 are 9 because it's 0.9 over 0.1, and that works out to 9. So that's the odds ratios just for A. Now in here we're going to do the odds ratio, and we're going to take the thing from A, so 9 as we figured out there, and we're going to put another subset or another sample on the bottom of that fraction. So we'll do the same thing for C here. But the test is pretty similar to the relative risk. So here we're saying that the odds ratio is not statistically different from 1 HO, and then HA says that that odds ratio is statistically different from 1. Again, they don't say anything about doing hypothesis testing or p-values in here, so we're not going to run those, but I'm using the confidence interval technique. So in this problem, if a given confidence interval does contain 1, that indicates that the two levels are statistically equal. If the odds ratio confidence interval does not contain 1, then that indicates that they are significantly different statistically. So let's go ahead and set this up. This again is going to be the same initial structure that we're starting with. So analyze fit y by x. just like we set it up from before. Here I just ran the Q205 script. And we're going to click on and we already have drop height in here, so we're going to do screen. And so let's first do 0.05 drop height with screens A and B. Okay, so I've now done my local data filter and I got the setup that I want. So 2 samples, the A05 versus the B05, and that's set up. So now what I need to do is go to my little red triangle here, and I'm going to press on odds ratio. And it's not giving me anything, which freaked me out for a second, but notice that the probability of B is 100%. So so that's probably what's tripping us up there. So let's just go to A and C. All right, there we go. That's better. And so for A and versus C at the 05 level, our resulting odds ratio is 4.33 with a confidence interval 0.462 to 40.608. So what that's saying is that could contain, or it does contain 1 in that interval. So therefore it would not be unreasonable to presume that odds ratio is equal to 1, and therefore it's not significant, even though those numbers are like scary big, the upper and lower boundaries. So so let's do that again for B and C, and again B having a 0 in it. We got an odds ratio of 0, and it doesn't compute the confidence interval. This one can be a 0 because, let's see, well, probability 1, no, because that individual odds of B is always going to be undefined because it would always have to have a 0 at the bottom. So, so that's that. So let's just switch this over here to 1, and same deal. So do all of those. And there's the odds ratios for that. So once you get through those, that'll be your 3-6. You'll have 9 confidence intervals and odds ratios thus far. And then what you have to do is you need a total of 18 confidence intervals, both on question 7, this one, and the previous one. Now what you got to do is go in and do each drop height pair for a screen. So let me see, I think this is going to have to get reran. And yeah, see, because it's not giving the odds ratios in there. So now what we have to do is go into, I'm just going to do a little hack here, go lower triangle at the top, redo relaunch analysis. That gives us the initial launch box that we used. So now what I'm going to do is I'm going to take out screen, and I do that by double clicking, and I'm going to swap in drop height and tell it okay, and that's going to open up a new output window here. So we're done with this one for now. We did our first 9 confidence intervals from that one. Now we're going to do the same thing for our second 9 confidence intervals in question 7. And you want to make sure and do this also for question 6. I don't know if I mentioned that or not back when we were doing that one, but same drill there. So add screen and add drop height. And for example, we're going to do level A, and we're going to compare 0.5 drop height and 1 drop height. So that's going to be, once I go up here and turn on odds ratio, we get our answer there. So that has an odds ratio of 0.506173 with that confidence interval. So that's going to be all of the calculations demonstrated. Got some grunt work to do, cranking out all those iterations. But hopefully that has enlightened you as how to get this thing calculated in JMP and get the information that they're wanting for. Let's see. So, can odds ratios be calculated for every comparison? Answer to that is no, because odds ratios involve a fraction that has the probability of failure on the bottom of it, and it's possible for probability of failure to be 0. That would be undefined, so that can't exist. So, any of those scenarios, they cannot be calculated for. And interpret the results for the comparisons that are considered statistically significant. So once you get all 18 of those cranked out, go through them and figure out which, if any, don't contain the value 1. In this example here, drop height 0.5 versus 1 at the screen type A level. Our odds ratio is 0.506, and that gives us a lower confidence of 0.14 and an upper confidence of 1.78. Because that upper confidence and lower confidence interval does contain the value 1, then that means that we have not found sufficient evidence to reject the null hypothesis here, and therefore there's not evidence that the two proportions differ. Therefore, they're found to be statistically equal, or as they would say in the question, not significant. So get all your 18 odds ratio confidence levels together, look through those, find the ones that do not contain 1. Those are the significant ones, and give a little explanation of that. So, all right, that's that. That was a big project. Provide a one-page summary, blah, blah, blah. If I get a chance, I'll maybe put something together on this later and repost that. But at this point, I'm pretty exhausted. That was a ton of work just demonstrating it. So hopefully that was of help to you in at least giving you algorithmic guides, step-by-step, that you can follow to getting this stuff put together and getting your desired output. So again, thanks for watching. Hope that was a help, and I'll talk to you later. Bye.